In this video, we're going to take a look at EventSentry's performance monitoring, but we're going to focus on SNMP this time, obtaining information from the remote host via SNMP. I have a firewall here in my test setup, and it's a pfSense firewall. I'm going to click that firewall here, hit check status up there, hit go to verify that that firewall is reachable, that I have the correct authentication set, and that works. So I can see a description here of the host. This is usually available with 99% of the SNMP based devices. I see the version of SNMP that's supported, so the highest supported version is version 2C. And of course we can see the little key icon there indicating that credentials are applied. If we click the host, we can see which credentials are applied. So firewall settings are applied here. Of course we can click on set authentication, have the same thing here again. And that's pretty much a prerequisite just to ensure that this host is actually reachable. So before we do anything related to performance counters via SNMP, we want to make sure we can actually reach that host. If we go into the web reports to the host inventory here, then we can also see the firewall here. We can see a little bit more information, how much memory is installed, network device, network cards, mount points. We can see performance counters that are already being monitored. So by default, EventSentry does have a performance system package that's assigned to all hosts. So if a network device, such as this particular pfSense firewall, does have SNMP installed and provides these counters, then we are going to monitor them. We can also see the running processes here. But we want to monitor additional metrics via SNMP. So we're going to go back into the management console here. Take a look at system health, and there's an option here that says import additional performance and SNMP system health monitoring packages. And it so happens that EventSentry does ship with a package for pfSense firewalls. So we're going to click this, we're going to switch this to registry files, and take a look at the folder here. We're in the resources folder inside the EventSentry installation folder, and the last one is the one that we want to take a look at, which is the health SNMP reg. So we're going to double click that. It's going to immediately show us all the available packages in here. And you can see here, starting with VMware all the way to UPSs, Fortinet, we have a pfSense. So we're going to check that, click import now. In a couple of seconds, we should see a new package down there called pfSense. Package is of course gray because it's not assigned. EventSentry does not know to which host we want this to be assigned. So we're going to click it, click assign, go to network devices, and assign this to our firewall. Now let's take a look at what's in here. So there's a bunch of counters in here indicating, measuring data about the firewall. So let's take a look at the first counter here. I'm going to just double click that. Here we can see the OAD that is being monitored. We have a descriptive name up here, so pf state table count. So you could call this anything you'd want. This is just a descriptive name. And of course, if we switch to Windows counter executable, there's nothing there. So we're strictly monitoring SNMP counters as is indicated here. That counter is being monitored every 10 seconds. We have no alerting set up, but we are writing this data to the database every 10 minutes. I'm going to make this a little bit shorter for this experiment to make sure we get some data soon. Now, if you want to make sure this actually works, then there is the test button. And the test button, of course, is now asking you, well, which host do you want to query? And we are going to select the firewall host here. Click OK. We can see here that this actually works just fine. We have average 50, 52, and so forth. So this seems to be working. So it's already connected to the firewall and is querying this data and showing us the current values. I'm going to go into every counter here and change this to 2 minutes just so that they are all the same. So this looks good. And all we have to do now is basically save and deploy the configuration. So now starting in 2 minutes, we should be seeing this information in the web reports. Of course, we could set up alerting here as well if there are specific thresholds that we're aware of. But of course, we're not interested in that for this particular example. Now, I did download a predefined package, but the process of doing this manually is exactly the same as it would be for any other performance counter, as illustrated in the video where we are monitoring the number of processes on a Windows machine. And it would be as simple as creating a package, just hitting the plus icon here, switching this to SNMP, and specifying the counters there. We are going to see those counters under the Performance tab. We are going to have to refresh that, however, to see that. It's not there yet. We can also see that information on the actual Performance status page, for example. So if you go to Current, and we pick the firewall here, that at the time currently we see those 4 counters here. So because, like I said, it takes about 2 minutes and a little bit of extra time for the agent to pick this up before the data is going to be displayed here. If you don't want to keep refreshing, then you can actually click up here and set a refresh interval, for example, of 1 minute, and then the page will automatically refresh. What you'll notice here as well, and this is interesting to point out, is that the SNMP engine here in EventSentry supports basic math calculations. So for example, the CPU utilization is actually the sum of the user and the system CPU utilization, and the memory is actually calculated also with a formula, as is the network bandwidth. So if you have multiple counters and you need to do some math in EventSentry, you can do that with EventSentry. Another thing to point out about SNMP monitoring is that it is actually the heartbeat monitor that obtains SNMP data from remote devices. Since EventSentry doesn't have agents for non-Windows devices, of course we're obtaining this data via SNMP, and the component that actually does that is the heartbeat monitor. And since the heartbeat monitor only runs every 60 seconds by default, so this is the monitoring interval that we have set, this may take a little longer because the heartbeat agent is actually only reaching out to that firewall every 60 seconds. So even though we have a interval set here for 10 seconds, the firewall is actually only going to get queried every 60 seconds because that's our main heartbeat monitoring interval that overrides everything. So if you have a lot of SNMP counters and you want a little bit more of accuracy, then we can reduce that monitoring interval. But of course, that's going to mean that there's going to be more traffic going to all of the network devices, because now every network device is going to get queried every 30 seconds, for example. But I'm going to change this here to 30 seconds and deploy the config here again. I'm going to do a manual refresh, and as you can see here, we now have 8 counters here. So if we click show all, then we've got all those counters here already. So how can we see them? If we click on detail, then we have a list of all the counters here. And we can focus on the ones that we just were looking at, which are the ones that start with PF. What we could do is we could simply say name PF star. And now we only see PF counters. And there we go. Removals, inserts, counter match, table count, etc., etc. So that information is now being queried from the firewall about every 30 seconds or so. And that is generally how simple it is to just get SNMP data reported and integrated into EventSentry's performance monitoring. So any sort of SNMP counter that exists on a remote host, you can simply add it to a performance package, specify the OID, and that data is going to get collected. And you may have seen in some of the other videos, or even with Windows performance monitoring, that Windows performance monitoring supports instances. So for example, when we're monitoring the CPU usage and a CPU has multiple cores, then we can monitor the CPU usage on each core, or we can monitor the CPU usage of each process. And all of these items are instances, so every process would be an instance. And that's supported for SNMP counters as well. And you can see how that works in the performance system package for the network, for example. So if we look at this performance counter that monitors the network utilization on both Windows and non-Windows devices, we can switch here to SNMP. We can see the calculations. So again, we're combining 2 OIDs here. We are excluding a number of interfaces. There's an additional calculation happening here where the counter values are being divided by yet another counter. There's also a multiplier in play. And we're also utilizing instances. So since in most cases a remote host is going to have more than one interface, and we want to see the actual name of the interface, SNMP supports tables, and we can utilize that by checking this box and pointing EventSentry to the OID that stores these tables. So looking at the OID path here, we can see that it's so the base OID here is 136121. So that's kind of always the same here. And then we have 22116, we have 22110, and then here we have 2215, and here we have 2212. So this is how this works. So this is how we can enable the instance and also tell EventSentry, well, which table has the actual name of these instances. And that way we get the same output that we would get on Windows, except that we're obtaining the data from SNMP. Another way to visualize how these instances in SNMP work is actually visible in our documentation. So if we scroll down here, you can see here another example. So here there's a different OID for monitoring the CPU utilization that actually includes the name of the specific core that's being monitored. So it's a kind of similar concept. Instead of monitoring the network utilization of a network interface, we're monitoring here the CPU utilization. And if we look at this table here, we can see you can see how each row has a different value. So that's the number on the very right is actually the CPU utilization of each core. So this would be a system that has 8 cores, whether they are logical, Hyper-V or not, or individual CPU is irrelevant here. But every row has a its own CPU utilization. But you wouldn't know which CPU each row is. So just because it says 5, you wouldn't know what actual CPU this corresponds to. And this is where the table, the index comes in, because here we're pointing it to another SNMP table that contains an actual string for each row that corresponds to this data here. So for example, if we were to look at number 7 here, then we would see, okay, that this is the CPU package ID node 060. So presumably the still the same CPU, but the core 7, since it starts with a 0. So that would be the 7th core. And here we have the description of the CPU. Now, in this case, this is somewhat superfluous, not really needed. But if we consider something like a network interface, then yeah, it would be very useful to know which network interface is the one that has the high utilization. And then the actual string would come in very handy so that you can actually see what is the name of the interface. So taking a look here, let's erase this here again. And our firewall, of course, has multiple interfaces. So this is what we can see here. So we got the network devices, network utilization, and here are the name of the instances. So this is all stored in the table, and we can correlate that with the actual data from a different SNMP table that then tells us, okay, well, what are these instances actually?